In this section, we're going to be multiplying and dividing rational expressions. So let's write out some instructions on multiplication. The handy thing about multiplying with rational expressions is just like multiplying with fractions, you do not need a common denominator, so that makes it a little bit easier. But I will tell you that our first step is going to be to factor the numerator and denominator. It's kind of the first step on lots of these problems. So factor the numerator and denominator. Then the second thing we're going to do is list the excluded values, which we also sometimes call restrictions of the domain. And the way we do that is to set each part of any denominators that you have that have a variable, set those not equal to 0, and solve for the restrictions. Then we will cancel legally. This is going to save us time, because if we cancel before we multiply, then we have less to multiply. So we cancel legally. That means you have to have an exact match with 1 in the numerator and 1 in the denominator. And it doesn't matter if it's in the left numerator and the right denominator, or the left and the left, or the right and the right. It doesn't matter. As long as one's in the numerator, one's in the denominator, you can cancel. Then we will multiply straight across. And once you've done that, you are not going to FOIL. So do not FOIL or distribute. We'll just leave things in parentheses. It'll be tidier that way and take us less time. Let's look at a couple of examples. For x squared minus 3x over 4x squared minus 1 times 6x plus 3 over x squared minus 7x. So remember that our first step is to factor. So we actually have 4 things to factor in this problem. We have 2 numerators, 2 denominators. So let's take it a piece at a time. The left-hand numerator has a GCF of x. So we'll go x times 4x minus 3. That's about all we can do there. The left-hand denominator is difference of squares. So we unsquare the 4x squared, which gives us 2x, unsquare the 1, which gives us 1. So that's going to be 2x plus 1 times 2x minus 1. Top right has a GCF of 3, so we got times. Take a 3 out, that leaves us 2x plus 1. And the bottom right has a GCF of x. So we just take out an x, and we're left with x minus 7. After we've factored, we're going to list the excluded values or restrictions. And remember that we do that by setting each part of all of the denominators that has a variable not equal to 0 and solving for x. So I'm going to go 2x plus 1 cannot equal 0. Subtract the 1 over. 2x cannot equal negative 1. Then I would divide by 2, and that gives me a fraction. X cannot equal negative 1/2. Moving on. 2x minus 1 cannot equal 0. Add the 1, so 2x equals 1. Divide by the 2, gives us another fraction. X cannot equal positive 1/2. Moving over, I see another variable, so I go x cannot equal 0. No work to do there, so that's just x can't equal 0. And then x minus 7 cannot equal 0. Add over the 7, x cannot equal 7. So we got 4 restrictions on this one. Next up, we're going to cancel. So remember, we can cancel exact matches as long as one pair is in the numerator, the other pair is in the denominator. So I've got an x here that cancels with an x in the denominator there. I've got a 2x plus 1 here that cancels with a 2x plus 1 in that denominator. And then nothing else matches exactly, so I just multiply straight across. So I've got 4x minus 3 times 3 over 2x minus 1 times x minus 7. And we're not going to FOIL that or distribute it, although it looks a little bit nicer if you write 3 times 4x minus 3 over 2x minus 1 times x minus 7. But that's just personal preference. It won't matter if you write it the other way. Okay, this one's going to look a little bit different. Oh, those negative exponents. Do you remember what negative exponents mean? Negative exponents mean that the base that they're attached to needs to move from either the numerator or denominator depending on where it's at. So this base of y needs to move up to the numerator, and when it does that, its exponent becomes positive. So now we have 2x to the 4th y squared over 10 times 5y cubed over 4x cubed. Now, before we would start canceling anything, let's get our restricted values. Our denominators, this denominator only has a 10 with no x's, so we don't need to set that equal to 0. The other one is 4 times x cubed. Well, the 4 doesn't need to be set equal to 0, so the only thing we need to worry about is x cubed cannot equal 0. And like if you think about that like x times x times x, that gives me x cannot equal 0, x cannot equal 0, x cannot equal 0. So really the only restricted value we have is x cannot equal 0. Now when you go to work with canceling in this format here, one way to think of it is like if you wrote it out in factored form, we would really have like 2 times 4x's times 2y's over 10 breaks down into 5 times 2 times 5 doesn't break down, but y cubed would be y times y times y, and then 4 is 2 times 2, and then 3x's like that. So if you wanted to write that in factored form, then you can cancel anything that matches in the numerator and denominator. So you can see that we have a 2 here that cancels with a 2 there. We have a 5 here that cancels with a 5 there. Then see how we have y's in the numerator and y's in the numerator? Well, that means they can't cancel because it's got to be a match in the numerator and denominator. So I can start canceling x's. This x can cancel that x, and this x can cancel that x, and this x can cancel that x. So what we'd have left in the numerator is x times y times y times y times y times y. So the numerator would be x times y to the 5th, and the denominator would be 4. Okay, on to division. Division with rational functions is just like division with fractions. So we're going to start out by factoring the numerator and denominator like we have every other problem. Then we're going to list restrictions. Here's where the steps change. We are going to keep it, change it, flip it. Do you remember what that means from fractions? That means you're going to keep the first fraction exactly like it is. Change division to multiplication. And flip it means you're going to flip the second fraction. So then we're down to a multiplication problem, and we just practiced that. But before we cancel anything, we are going to list new restrictions. Well, where do those new restrictions come from? Because we flipped the second fraction. So we have to see if there's any new restrictions. Then cancel legally and multiply straight across. Let's look at a couple of examples. So we'll do r squared plus 5r minus 14 divided by 4r squared minus 4r, and then divide by r plus 7 over r cubed plus 3r squared minus 4r. So we're going to start by factoring. R squared plus 5r minus 14 is going to use the AC method. So just to save time, I'll go ahead and factor it for us. That is r plus 7, r minus 2. The bottom left is going to have a GCF of 4r. So it will be over 4r times, divide out 4r leaves me r, negative 4r divided by 4r leaves me minus 1. Then divide by. R plus 7 is already simplified, so it stays r plus 7. And the bottom right has a GCF of r, so I'll go r times r squared plus 3r minus 4. And then I'm going to need the AC method. So I'll have r times, and again, just for the sake of time, I'll factor that for us, so it's r plus 4, r minus 1. So once we have it factored, the next thing we're going to do is list restrictions. So we have to say what r cannot equal. We go piece by piece, so I have 4 times r minus 1, and r times r plus 4 times r minus 1. So I don't worry about the 4, it doesn't give me anything. I set r not equal to 0, that gives me r can't equal 0. R minus 1 not equal to 0 gives me r cannot equal 1. Set r not equal to 0, that gives me r cannot equal 0 again. R plus 4 cannot equal 0, gives me r cannot equal negative 4. And then r minus 1 gives me that same one that I had before. So I have 3 restrictions right now. And then the next thing I'm going to do is keep it, change it, flip it. So keep it, I keep the first fraction. So it stays r plus 7 times r minus 2 over 4 times r minus 1. Change it. So now I make it multiplication. And then flip it. So I'm going to put the denominator on the numerator, so r times r plus 4 times r minus 1. Put the numerator on the denominator, r plus 7. And then before I start canceling, I have to remember to list new restrictions. And the new restriction is going to come from the new denominator. So I have to set r plus 7 cannot equal 0, which gives me r cannot equal negative 7. So now I have 4 restrictions. Then I can cancel. So remember, I have to cancel something exactly matching the numerator in a denominator. So I can cancel this r here with this r here, and r minus 1 with r minus 1. And if I put this r plus 7 in parentheses, then I can cancel it with this r plus 7. And then I multiply straight across. So I'm going to have r minus 2 times r plus 4 divided by 4. And that will be my simplified rational expression. Okay, let's do one like we did on the multiplication side that just has variables and coefficients and negative exponents. Don't forget those guys. So 3x cubed over 5y squared divided by 6y to the negative 3 over 5x to the negative 5. So before we really get started, we want to deal with those negative exponents. Remember, a negative exponent means it's going to take its base and move the base to where it wasn't. So the y to the negative third goes to the denominator and becomes y squared. And x to the negative fifth brings the base of x to the numerator. So now I've got 3x cubed over 5y squared divided by 6x to the fifth over 5y cubed. And then I guess if you want to think about this in terms of factoring it, we could rewrite this as 3 times x times x times x over 5 times y divided by 6 times x over 5 times y times y times y. So that when we get our restrictions, we don't worry about setting 5 equal to 0, but we do set y equal to 0, not equal to 0. So y cannot equal 0, y cannot equal 0. Don't worry about the 5. Y cannot equal 0, y cannot equal 0, y cannot equal 0. So we really only have one restriction right now. And then we're going to go ahead and keep it, change it, flip it. So that means I'm keeping my first fraction, so 3xxx over 5yy. Changing division to multiplication, and then flipping my second fraction. So now I have 5yy over 6, and then I got 5 x's there. Check for new restrictions. I do have new restrictions. I don't worry about the 6, but I have x can't equal 0, x can't equal 0, x can't equal 0. So my restrictions are y can't equal 0 and x can't equal 0. And then I'll move on to the canceling phase. Oh shoot, I forgot to break down my 6. I could break down my 6 into 2 times 3. That'll make it easier to cancel. Because now I can see that I can cancel this 3 and that 3, the 5 and the 5, and then I have an x and another x and another x. And I've got a y and another y. So what's left in my numerator is a single y, so y over the denominator. I have 2 times x which is 2x squared.